And this was my first exposure to making software work in the real world. This ability to write code very easily and measure the world, and manipulate the world, and create robots that children could use was amazing. I couldn't believe it. And so my children were bored by the robots, and they said, I want a better robot. And so I thought, well, maybe the robot could fly. And so we put the Lego on a plane, and the plane flew, and it became a Lego drone, which is now in the Lego Museum in Billund, Denmark. And that was amazing. I couldn't believe that my children and I could build a flying robot. And so I created a website to sort of really ask, what's going on? How is this possible? And people started answering my questions. And it turns out that other people were thinking the same question. You know, what's in a smartphone that can be used in a helicopter? What can I do with these new sensors that are in our iPhone? What can I do with the cameras and the GPS and the radio? It's so good and so cheap. And these technologies, which used to be available only to the military, are now in our pockets. What can we do with them? So we created a website. People started contributing. They started innovating. They started creating technologies. And so the next generation came along and they said, that's great, but I don't know how to code. I don't know how to solder. Can you just do it for me? And so we created a company. And this is what the company looked like. This is my children building our first robot. It was a flying blimp, a balloon. We packed them in pizza boxes, and I thought that was the end of it. But the problem is that people kept buying them, and so we had to make more, and I couldn't get the children to make any more blimps. So I found a guy on the internet, Jordi Munoz, who I later discovered was a 19-year-old high school graduate in Tijuana, Mexico. And he agreed to solder some boards together for me. And I thought that was the end of it. And then he kept sending me pictures. He says, I've got a new space, 2010. And I thought, that's great. He's got shelves. He's got people helping him. Amazing. I thought that was the end of it. And he said, I've got a new space. I've now created a factory. I bought machines from eBay. We learned how to use them by downloading instructions from Google. We have pick-and-place machines, and stencil printers, and reflow ovens, and CNC machines. And I was like, oh my God, this guy's amazing. And then he sent me another picture. He said, we've opened a second factory in Tijuana, Mexico. This is the clean room. I thought, they have uniforms. Who knew? And then he says, and the factory's bigger. And this is what happens when teenagers in Mexico, using credit cards and the internet, build an aerospace company. And at this point, I quit my job as editor of Wired, and I took over as CEO when we raised venture capital, and today we're a big company. But this is what happened in a small number of years. You going from toys and my children to a high-tech, global aerospace company in a matter of about 3 years, using nothing more than credit cards. Now today we look like a traditional company. Today we're venture-backed. Today we, have, teams of professionals, factories in China, but we didn't start that way. We started like the Kickstarter generation. We started like entrepreneurs everywhere, which is basically on the kitchen table and in a garage, just doing it because we could. And that's what I mean by a new industrial revolution. We know that software companies can start that way, but now hardware companies can start that way too. This is the kind of stuff we make. We make drones, and this is how we've now thought about this. We used to think that the only way you could do hardware was in China. We used to think that the tides of globalization were all going east, that it was about cheap labor. And now we realize that we have the ability to do things here and there. You can prototype on your desktop. And then you can send things to China to make 100 or 1,000 with cloud manufacturing. And then if it succeeds, you can build a local factory using the same robots, the same machines that the Chinese use. Digital manufacturing has become global. that as things become more automated, they become, the playing field becomes flat. Everybody buys robots for the same price. You can buy a pick-and-place machine or a CNC machine here in Italy at the exact same price as they do in China. And because it's a robot, the labor costs don't matter. And so once you get to, you can do 10,000, maybe 100,000 locally. That's a great way to explore the market. Then if it goes really mass, maybe you send it back to China to take advantage of the supply chains there. But this ability to kind of move back and forth between close to market, close to your innovation hub, or far away, where manufacturing is more concentrated, this ability to move things around is what's so great about digital manufacturing. It allows us to manufacture where it makes most sense. Sometimes it's mass, sometimes it's micro. Sometimes it's just in time, local. Sometimes it's batch process for classic retail distribution. This was not possible before. It used to be a one-way street. It's all to China. And now it's a back and forth. This is a factory right next to my office in Berkeley, California. This is a furniture factory. And what I love about this picture is that it's a glimpse of the 21st century. This is what a furniture factory looks like. It's one robot, the yellow robot here, the Fanuc arm, loading another robot, the CNC machine, behind it. And at the beginning of the day, they stack these aluminum blocks. And the robot just takes one aluminum block, puts it in the other robot, it's turned into furniture, and then takes it out and stacks it in another stack. And the only human jobs in the whole factory are this guy in the background, Harold. He programs the robots, and he's essentially an engineer. And then there's a couple guys who empty out the trash through the aluminum filings that go into the recycling bin. And this is sort of a metaphor for the 21st century manufacturing world. There's only two human jobs left in the factory. You either program robots or you take out the trash. And so, as we train a generation for the 21st century, you have to ask, which do you want to be? Do you want to program robots or do you want to take out the trash? Now that sounds like a bad choice, right? Programming robots sounds complicated and taking out the trash sounds like no fun. But thanks to the new industrial revolution, programming robots looks less and less like a technology job and more like a design job. My children, and perhaps your children, are growing up in a world where these tools, 3D printers, CNC machines, CAD, are in the classroom. Where they are learning, where in the past they learned how to do PowerPoint or spreadsheets, they're soon going to be learning how to do digital design in class. And it's going to be as easy as playing Minecraft. And those skills, the ability to turn ideas into a digital concept on a screen and then press a button and have robots do the work, these skills are going to be as easy for them as word processing was for us. And so tomorrow, programming robots is going to look like playing Minecraft. And that's why this is such an encouraging picture of the future. Let the robots do the boring work. Let us do the creative design work. And the tools of the new industrial revolution are making that easier. So I wanted to end on one note before we take questions. These two men reflect the 20th century and the 21st. On the left, Ronald Coates, who created the concept of the 20th century firm. It was built around minimizing transaction costs. Why do companies exist? To make it easier to get things done. If people have assigned roles, jobs, responsibilities, you know who does what. She does accounts receivable, he does accounts payable, and everybody works in one office, under one roof, with clear titles, to get things done. Bill Joy, on the right, one of the co-founders of Sun, challenged this. And what he said was, whoever you are, wherever you work, most of the smartest people in the world work for somebody else. Now this is true, but what are you going to do about it? And Bill Joy didn't have an answer. But today, we have an answer. Open innovation is the solution to Joy's paradox. We know the smartest people in the world for any given job are not here in this room, are not working for our companies, are not even in this country, but we don't know where they are. How do we find them? Maybe they're Chinese, maybe they're Indian, maybe they're African, maybe they're Brazilian. We don't know. And in the old model, we couldn't find them. They didn't go to the right school, they don't speak the right language, they don't already have the right work history. Maybe they're 14, maybe they're 75, maybe they've never been to college at all. We don't know in the old model because we don't know how to find those people. In the new model, in the web's innovation model, we don't have to find them. They find us. We create platforms for innovation. We create communities, and smart people find communities. If you give people a way to contribute, smart people will find a way. This is what we did with DIY drones. This is what open innovation around the world is starting to do. This is what the open source software movement did. This is what platforms like the App Store for Apple or the Android App Store do. This is increasingly the way all successful companies are working. They're creating ecosystems, opportunities for innovation to come from outside the company itself. What we've learned by building an aerospace company along these principles is that you can't beat open platforms for innovation. In a new industry where you don't know where the applications are, the only way to find out is to open it up and let the users tell you. Apple created the Macintosh, but we figured out what it was for. Scientists created the internet and the web, but we, the users, figured out what it's for. Apple created the iPhone, but all the thousands of companies that created apps figured out what it was for. And that's what open innovation looks like. In our company, it's really simple. We just sort of say, here's the project. Here's some jobs that need to be done. And then we say thank you. When people do a job, we just give them something like a t-shirt and say, we recognize your contribution, thank you. And they love that. If they go further, we give them hardware discounts. This is not why they're doing it. They're doing it because they can. They're doing it because we helped them get a job done. They're doing it because it's fun. They're doing it because it's their passion. All of these recognitions are just our way to acknowledge their work. But as they get further into it, it becomes an obsession. They turn it into a job before we ask them to. And all we do is just recognize their contributions. Eventually, after they've done all of this, we hire them. Almost all of our employees came out of our community. Almost all of our employees were working for us before we hired them. They were working for us as volunteers. They were working for us at night. They were working for us because of their passion and enthusiasm for the space. And only after that do we hire them. And they turn out to be the best employees because they've already proven their ability to do their job. There's no risk associated. By the time we've hired them, they've been working for us for years and will earn the respect of the community and their colleagues. It's the easiest hiring in the world, and it happens automatically because we created the architecture of participation. Platforms are magnets for talent. If you create an opportunity for people to innovate, they will. If you create an opportunity to recognize and highlight innovation, the best stuff will rise to the top. This is the innovation model of the web, and this is increasing the innovation model of all companies everywhere. So I just wanted to end with this note, that this is what it looks like to me. As we look back from the origins of the Industrial Revolution to the new Industrial Revolution, you can see this change. Back in the old days, it was company versus company. They owned the means of production. Only those who owned factories could produce. Then, in the 20th century, factories became more widespread. Everybody could have access, any company could have access to a factory, but the question, and then it became product versus product. Less about the means of production, and more about what you're producing. But in the 21st century, it's not just a product. only the platforms, only products that are also platforms will win. And so we're seeing Android versus iOS. We're seeing, Facebook versus Twitter. These are examples of platforms. And as we move into the Internet of Things and wearables, smart homes and all that, every one of those new markets will be won by platforms, not products. Behind the platform may be a company. The platform may be shipped in the form of a product, like an iPhone, but if it's not a platform, it won't win. So that is the shape of the new industrial revolution. It looks like the web, but it's much, much bigger. Thank you very much.